warm welcome to the module on ideal gas equation. I think we are familiar with the term ideal in our daily life. Sometimes we call some students as ideal students. When we call them like this, anybody can answer? Yes, those who obey the rules or laws are called ideal. If the very same case is applicable to the gases also. So we can say that a gas that follows Boyle's law, Charles' law and Avogadro's law strictly is called an ideal gas. We can say that such gas is a hypothetical gas. It is assumed that intermolecular forces are not present between the molecules of an ideal gas. That's why they can behave as an ideal one. Real gases follow these laws only under certain specific conditions. That means when the force of interaction are practically negligible. We can study it later. In all other situations, these gases deviate from ideal behavior. Now, we will try to derive the equation for an ideal gas. For this, you have to write the representation of Boyle's law, Charles' law and Avogadro's law. What is the representation of Boyle's law? At constant temperature and number of moles, volume is directly proportional to 1 by P. What is the representation of Charles' law? At constant pressure and number of moles, volume is directly proportional to temperature. And for Avogadro's law, at constant pressure and temperature, volume is directly proportional to N. In all the case, you can see that volume is directly proportional to 1 by P, volume is directly proportional to temperature and volume is directly proportional to N. So you have to combine all these equations. So what you will get? V proportional to 1 by P into T into N. We can replace the proportionality by a constant. So what we will get? V is equal to R into 1 by P into T into N, where R is called a constant called universal gas constant. We can rearrange this equation, so we will get PV is equal to nRT, where P is the pressure, V is the volume, N is the number of moles, R is the universal gas constant and T is the temperature. This equation PV is equal to nRT is called ideal gas equation. Dear students, so we learned about ideal gas equation. What is that equation? PV is equal to nRT. So I will ask one question. How many variables are present in the ideal gas equation? Yes, it's 4. What are they? They are pressure, volume, temperature and number of moles. And by using these variables, we can describe the state of the system of gases. So, this equation can also be called as equation of state. In the ideal gas equation, there is one constant called as universal gas constant and it is denoted by R. Now, we shall find out the value of universal gas constant. For this, we have to first write the ideal gas equation. You all please write the equation ideal gas equation. How you all write this equation? Yes, PV is equal to nRT. We have to find out the value of R. So what do we have to do? We have to rearrange the equation, that is ideal gas equation. PV is equal to nRT to R is equal to PV by NT. Then we have to substitute the values of pressure, volume, number of moles and temperature. You will get the value of R. But we all know that volume of 1 mole of an ideal gas under standard temperature and pressure conditions is 22.7 liters. What is the condition of standard temperature and pressure? Yes, it is 273.15 Kelvin and 1 bar pressure. So substitute the values in the equation, you will get the value of R. First value of R is 8.314 Pascal meter raised to 3 Kelvin minus 1 mole raised to minus 1. Another value is 8.314 into 10 raised to minus 2 bar liter Kelvin minus 1 mole minus 1. Another value is 8.314 joule Kelvin minus 1 mole minus 1. You have to study these values very well and you have to look on these units of this value, then only you can solve the problems. Dear students, hope you all understood about the ideal gas equation and universal gas constant and what are the values of R. Thank you dear students, thank you. We will meet in the next module.